So prior to this, we learned about area of a parallelogram. We also learned about area of a triangle. So now we're going to move on to area of a trapezoid. Just in case you don't know what a trapezoid looks like, looks just like the title here. Trapezoid. All right, so a trapezoid is a figure or shape with exactly one pair of parallel lines. And because trapezoids can come in a wide variety of looking, so I'm going to go ahead and draw what some trapezoids could look like. And I'm going to draw them kind of on the sides here, just so that you have a visual of what a trapezoid could look like. Of course, it could look like this. Everybody with that? It could look like this. It could look like that. Let's see. It could look like this. Ultimately, as long as it has two sets of parallel lines, I said that wrong. As long as it has one set of parallel lines, has to have exactly one, not two like the parallelogram or a rectangle, but only exactly one set. So here, my parallel lines are here and here. My parallel lines are here and here. Parallel lines are here and here, and parallel lines are here and here. I do recommend that you use a highlighter to help you highlight your set of parallel lines to make sure you can visually see that. All right, so the formula for finding the area of a trapezoid found on our nifty little mathematics chart that the state of Texas says that everybody can have. We found a trapezoid and we followed along. Bam! And there it is. I'm going to write that out. 1/2 B1 plus B2 and this H. Whew, that looks kind of difficult. I know that was actually a question that was on your benchmark test, and some of you go, Miss Armstrong, I had no idea what a B1 and a B2 was, so I didn't know what to do. All right. So I'm going to write a few notes down here at the bottom that might help me. So remember a couple days ago when we first started areas, one of the things I told you is I could give you all the formulas in the world, but if you don't know what those letters stand for, there's no way you're going to be able to do it. I gave you this formula. This formula was on your star chart when you did the benchmark, right? You've had this formula all year long. However, it's not going to help you until you know what they are. So let's go ahead down here at the bottom. Let's go ahead and define what each of these letters are. B1, B2, and H. Well, what do you think H is?
Height.
Height, very good. Height of trapezoid. That was pretty easy. All right, so remember we came back up here and here it said that there was exactly one set or one pair of parallel lines, right? And if it's a pair, how many lines does it have? Two. All right, so don't you think that maybe this B1 is considered to be base 1, and this B2 is base 2.
Yes.
It doesn't matter which one you choose to be base 1 or you choose to be base 2. Me, myself, I always do the top one base 1 and the bottom one base 2, but it doesn't matter. Okay? When we talk about our height, your height for a trapezoid will always connect both bases. And then therefore it will form a 90-degree angle. Everybody with me on that? All right. Do what? We're gonna go ahead and label these over here. So now we kind of have a little bit more understanding of what a B1 and B2 is. Now let's go ahead and look at our figures that we drew over here on the side. Yes, the height should connect both bases. All right, so let's look over here at all of my figures that I drew. And I'm going to go ahead and label. So here is my set of parallel lines that I highlighted. This is going to be base 1, base 2. And then my height will connect those two bases. Guess what it forms with the base?
90-degree angle.
90-degree angle. Isn't that what we talked about?
Yes,
That your base and your height have to form a 90-degree angle?
Yes, ma'am.
All right. Right here, here is my base 1, my base 2. And then my height connects the two. Base 1, base 2. This time, my height is actually a side of it, correct?
Oh, yeah.
It connects base 1 and base 2, doesn't it? Forming a 90-degree angle. And then here's my base 1 and my base 2. All right, so let's go ahead and label the bases and the height of each of these. Base 1, base 2, height. Base 1, base 2, height, because it forms a 90-degree angle here. The height must be perpendicular to the parallel bases. Perpendicular means it runs up and down. All right, let's try one example and then we'll work some more after we do these notes. Find the area of the trapezoid. Show all your steps. First step is I'm going to write my formula. A equals 1/2 B1 plus B2 times H. Plug in my numbers. Do I know my area?
No.
No. Do I know my base 1?
Yes.
All right, I'm going to highlight my bases. Base 1, base 2, and my height. Plugging in what I know. My 1/2 stays the same. Base 1 is 4. Base 2 is 6. And my height is 3.5. Order of operations, tell me I'm going to do what first? Right, Eric?
You're going to do the parentheses.
Awesome. I'm going to do my parentheses. 4 plus 6 is 10. All right. Half of 10 is?
5.
And then 5 times 3.5. What do I have to do? I've changed that 3.5 to what? Go ahead.
3.5.
I could change it to a decimal. I could also change it to a what? Mixed number? Or I mean an improper fraction?
Yeah.
And so it would be 5 times 7 over 2. And it would give me 35 over 2. So my area would equal 17 1/2.
Yes, ma'am.
No naked numbers. Inches what?
Square. Inches.
Squared. All right. In the next video, we will be doing some more examples of area of a trapezoid.